Hello everyone and welcome back to another project. In this project, I'm going to show you on how you can control your drone using your hand gesture based on computer vision. So for this part of the project, I will be limited within the simulation only, but in one of the later videos, I will show you on how you can upload the entire code on single board flight computers like Raspberry Pi and then connect with your flight controller like which is in my case the Radio Link SpeakSock, and then control your drone using your hand gesture from the ground station by using telemetry over Wi-Fi or LTE. So I'm using the same virtual environment that I have already shown you in the previous video, the configuration part I mean. So I'm not going to be showing that for one more time. Rather, for your reference, for the sake of your convenience, I will be attaching the link of the previous video in the description box below. And as I've already told you that the Python version, the version of all the packages that I'll be using are same as before, as I have already shown you in the previous video. So without any delay, I would like to initialize my system. So as you can see that I have Mission Planner ArduPilot open in one of the windows. So right now I'm opening up a new terminal to initiate a DroneKit SITL. So as you can see, DroneKit-SITL copter dash. This is these three coordinates represent my home latitude, longitude, altitude, and heading. So I'm hitting enter. That will be initializing the TCP port 5760, as you can see. So right now I would like to initialize the MAF proxy that will allow me to connect with the Mission Planner using the virtual environment. So I believe that it is getting connected.
Calibration
as
complete.
You can see that the calibration has begun.
Quad.
That means the vehicle is the virtual vehicle, which is the virtual copter, I should say, is connecting with ArduPilot.
APM copter version 3.3.
So as you can see that the system is initializing. So right now I must be ready. Yes, as the system has been initialized, the simulator has been initialized, I'm ready to run the main code. So right now I'm ready to run the main code. In the first part, I will show you the continuous navigation of the drone based on the hand gesture. And in the second part, I will show you the discrete navigation of the drone based on the hand gesture. So with no delay, I would like to run the code. As you can hear the audio feedback that the ArduCopter is initializing, and it will be connecting with the Mission Planner that will eventually allow me to visualize the simulation. So very shortly, the video feed would be popping up. So as you can see that there is the video feed screen which has popped up right now. So there is a virtual zone, rectangular virtual zone, as you can see, and I have mapped the rectangular virtual zone into the physical space having a dimension of 80 by 80 meter. You can see that there is a virtual copter at the very center of the virtual zone, and the position of the virtual copter would be mapped to the target waypoint of the drone which is situated in the physical space. That means the target waypoint of the drone which is situated in physical space is mapped according to the position of the virtual copter within the virtual zone. So as I drag and change the position of the virtual copter, the position of the actual drone situated in the physical space would also be changed accordingly. There are 4 other types of gestures that I'll be using using my left hand for takeoff, climb, descent, and return to launch or RTL. These are the other 4 commands that I'll be using other than dragging the virtual copter using my right hand. So the virtual copter will not go beyond the edges of the virtual zone. Similarly, in the physical space, the actual copter won't neither go beyond the edges of beyond its limits, which is mapped according to the edges, according to the limits of the virtual zone. So I believe that I have been able to clarify what I'm really going to do in this part. And right now I'd like to arm and take off the vehicle using the left hand gesture. I mean using the thumb of my left hand. So as I show this sign, as you can see that the mode has been changed to guided.
Initializing APM.
The copter has been armed, as you can see, and it's climbing to its target altitude. Okay, let me minimize it. Yes, as you can see that the vehicle is climbing to its target altitude. You can see it in the video feed as well. You can see it on Mission Planner. So the target altitude is 12 meter. Now, if you want, you can also increase the altitude simply by showing the victory sign using your left hand. So as I'm showing the victory sign, you can see that the altitude is also increasing. It will be something around 22 meters. And if you want, then you can also descend simply by showing this sign. So in that case, the vehicle will be descending. So that's how the arm and takeoff, the climb up, and the descending gestures work. Now the main part is the navigation of the drone along the XY plane. So I can drag and change the position of the virtual copter situated at the virtual zone using the tip of my index finger. So as you can see, the virtual copter has changed its final position. As well, the copter, the drone situated in physical space, is also moving accordingly. I mean, the position of the virtual copter has been translated into the position of the actual drone situated in the physical space, as I have already told you. So let me drag it to somewhere around here, and let's see if the drone is moving. As you can see that the drone in the physical space is moving accordingly, and it's also showing us the distance from to the target waypoint, distance from home, and all the parameters that you can see in the quick action panel in the prime flight display as well. So as I've already told you that the target waypoint of the actual copter is mapped according to the final position of the virtual copter situated at the virtual zone. So let me move the position of the virtual copter to somewhere around here and see if it's working. You can see the altitude, the flight mode, the moving means the distance which is left to the target waypoint, which is same as you can see in the hub in the quick action menu in the prime flight display, I should say. So you can see all the information are changing according to the gesture command, and you can move the drone to any position as you want. Let's get it close to the home position, and you can see that the drone would be returning to its home position. That means the gestures are working perfectly. If you want, then you can also increase the altitude. So let's wait until it's until it has reached its target waypoint. It has reached, so we can increase the altitude by 10 meters. I mean, the step is set to be 10 meters in the program. As you can see that the altitude is 22 meters, and let me move the position of the virtual copter somewhere around here, say. So it's moving to the left backward position. As you can see in the map on mission planner, that the position of the copter is changing according to the position of the virtual copter. So from that waypoint, from the last waypoint, I will be initializing the RTL command, and I believe that I have been able to show you the demonstration correctly, that the actual position of the actual copter moves according to the position of the virtual copter situated in the virtual zone, and I can drag the position of the virtual copter using my fingertip as I have already shown you. So let's move for one more time somewhere around here. Yes, and I believe you can see that in physical space the copter is also moving to the target waypoint, which is mapped according to the position of the virtual copter within the virtual zone. So that is the last waypoint from where I will be initiating the RTL using my left hand, using the by raising the 5 fingers of my left hand. So I'm ready to initialize the RTL command.
Mode changed to RTL.
As you can see that the flight mode has been changed to RTL, and the vehicle will be returning to its launch position, to its home position. So as you can see that the vehicle is returning to its home position, and it will be descending right now. Yes, the altitude is decreasing, as you can see here. As well you can see in the video feed that the altitude is gradually decreasing, and just after landing the vehicle will be disarmed as well. So let's wait a bit and see if it's working perfectly. So the altitude is gradually decreasing, as you can see. Yeah, the vehicle has landed, and
Disarming
the motors will be disarmed, and as you can see that the motors have been disarmed. So that's how the drone can be controlled using your hand gesture. So for the XY plane, for the movement of the drone along the XY plane, I have dragged the virtual copter. Right now, whatever I do, I mean, nothing will change because the vehicle is not armed as well. It's not in the air. So the XY movement has been done by dragging the virtual copter within the virtual zone, and the movement along the Z axis has been done using the gesture of my left hand. I have already shown you all the gestures. So in the next part, I will show you on how you can perform the discrete navigation of the drone. So right now I'll show you the discrete navigation of the drone, where I will be using a set of discrete hand gesture to control the position of the drone. I mean, in this case, I will be able to move the drone forward, backward, left, right, and there are some more gestures that I'll be using for arming and taking off the vehicle to a target altitude, climb up and descend, and finally to return to its launch position or initiate the RTL command. Like the previous feature, we cannot move the drone freely along the XY plane. That's why I'm calling it discrete navigation. So with no delay, I would like to run the code.
APM copter version 3.3.
So as you can hear the audio feedback, the system is initializing, and the video pop-up should be coming up very shortly. So like the previous part, there won't be any virtual zone, as you can see, and I can arm and take off the vehicle to the target altitude, which is 12 meters in our case, simply by using the thumb of my right hand. So as I'm using the thumb of my right hand, as you can see that the vehicle has been armed and it will be climbing to its target altitude of 12 meters. So as you can see that the target, it has already achieved its target altitude of 12 meters. If you want, you can increase the altitude simply by showing the victory sign using your right hand. So I believe you can see that the altitude is increasing and it will be getting down to 20 meters. And you can also descend back by showing this sign, and the step of the climbing or descent for each of these gestures is 10 meter. So the vehicle is descending. Yes, it is right now at 12 meter. So right now I would like to move forward. So this is the command, the victory sign using the left hand, that will be used, that is used for moving forward. Let me go a bit more forward. I believe you can see that the distance to the target waypoint, the altitude, and the flight mode, as well you can see the things on the primary flight display, as I've already told you. Now let's go to the right by 10 meters. After that, I will move forward and create a zigzag trace or zigzag path, as you can see in the mission planner map tool. Now let's go forward by 10 meters. Then I will be moving left by 10 meters. I believe you can recognize the hand gestures. Right now I will be moving left by 10 meters. Again move left by 10 meters. Again move left by 10 meters. Yes, it's moving. I believe you can see the distance to the target waypoint and all the information in the primary flight display. And then I will be moving back by 10 meters. Then move right by 10 meters, and you can see that it has created a beautiful zigzag path as expected. So let's move to the right from where I will be initiating the RTL command. And the step size, either for moving left, right, forward, backward, for climbing or for descending, it is 10 meter. The step size for each of these movement is 10 meter, as I have already told you. So let's move to the last waypoint from where I will be initiating the RTL simply by raising 5 fingers of my right hand. So right now I would like to initiate the RTL, or the return to launch mode.
Mode changed to RTL.
As you can see, as you can hear from the audio feedback, that the RTL command has been initiated as I had shown the 5 fingers of my right hand. So the vehicle is returning to its home position. It's currently above home. As you can see, distance to home, it's very short. That means it's hovering at the home position. It will be hovering for 5 seconds, after which it will be initiating the descending procedure. So it's descending right now, as you can see, and just after descending, the motors will be disarmed. So it's currently at 4 meters, 3 meters, and touchdown very shortly. Yes, the vehicle has touched down and the motors will be disarmed shortly.
Disarmed. Disarming motors.
So I believe I have been able to clarify the simulation. as I've already told you that in one of the later videos I will show you in practice on how you can deploy the entire thing on single board flight computers like Raspberry Pi and then control your drone remotely from the ground station using the hand gesture by using telemetry over LTE 4G or by using Wi-Fi. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.